Do any of you have any questions for me before we start this lesson? I'm glad you were all right. I just got power back myself, so I didn't get to have my morning class. Anybody have anything? All right, well, I will share a screen with you, and we're going to look at our last section in chapter 4. Um, I really would like for everybody to do well on this. So, what I'm thinking is I might adjust the schedule and take 2 days to review. Um, what I'm planning on doing is posting a review in Math Lab. So, I'm going to go ahead and record so everybody can hear this part. Um, just so they'll hear the part that I'm about to say about the test. All right, so we'll just see, but my plans are right now to finish the chapter today and review Tuesday. So what I'm going to do is I'm going to post a review in your module. It may already be posted. So it'll be a printable review or one that you can download and work on your paper. And what I'm going to plan to do is add a submission box for that so that you can earn bonus points for doing the written one. There's going to be one in Math Lab that I'm going to require because I'm going to try to do your test in Math Lab using Honor Lock. And I'm going to be posting some specific directions. Some people had a little trouble using Honor Lock last time, but I think I've got a set of directions that's very clear. And we shouldn't have any issues, hopefully, by next Thursday. Um, we'll try to do our test in Honor Lock. Now, anybody that wants to come to campus can come to campus to take the test. But the reason that I'm doing it in Honor Lock is because I can't create a test in Canvas that compares to the seated test very easily. So that's why I'm going to do the test in Honor Lock. It's really easy for me to do a test for seated classes. It's very difficult for me to do a fair test on the computer. So I feel like Math Lab is the most fair way that I can make sure the two tests are as equal as possible. So we'll offer a test on campus and we'll offer a test on Math Lab using Honor Lock. And I'll be posting all those directions for you, possibly even as later today or in the morning. But you can go ahead and be working on that study guide after I go over this lesson. What else was I going to tell you? So the test I'm planning on being next Thursday. I'm pretty flexible about what time you take your test on campus. I just have a class from 9:30 to 11. So anytime after that would be the best time for me. I can obviously give it at 1 o'clock during the normal test time. So does anybody have any questions about the test? Well, the one in Math Lab, I really just want you to actually do the one in Math Lab because I assigned 20 points to it. So it would be, it'll be like a homework grade. So, I mean, it won't kill you if you don't do it. I'm going to drop probably the 2 or 3 lowest Math Lab grades or homework grades anyway. So if you don't do it, it's going to get probably dropped anyway. It's up to you. I just feel like it was really good practice and it was some good problems on there. But actually, if you don't want to do it, it's going to get dropped anyway if you're going to take your test on campus. I just think if you're going to take your test on Math Lab, then it's a really, really good idea But I suggest both of them just simply because it's good practice. And this is probably stuff that's new to you in this class. I'm not sure to all the students. A lot of it's probably new, and practice makes you better at it. So I feel like the more practice you can get, the better off you'll be. But I do plan to drop the lowest 2 or 3 daily grades or assignment grades. So if you don't do it, it's not going to hurt you because it's going to probably get dropped anyway. But I will be posting some more information about when the test will open, when it'll close, and on campus testing. And you can just kind of let me know. I would like to give the test at 1 o'clock, but if you want to take it earlier, that's fine, as long as I have that class from 9:30 to 11. So they're not taking a test that day. So I'll be teaching. I also want to mention that I'm going to add the logarithm formulas to the formula sheet. So I will have a new formula sheet posted in this module that you can use for this test. This section is using all of the definition of logarithms, one-to-one properties, all the properties that we learned in 4.3. This section use all those to solve exponential and logarithmic equations and to use applications of those. So we're going to use light bases to solve, logarithms, definition of logarithms, one-to-one property, lots of different properties that we're going to use. So here's some strategies that you can refer back to. You won't have these on your test, but once you work a few of these problems, you'll kind of learn what the strategies are. So basically, you want to look at your problem when you first get it. And if you see an equation that has only a single logarithm, then you want to probably use the definition of a logarithm. Okay, that's when we use definition of a logarithm. There are sometimes when if you have either like exponentials, like bases on both sides of your equation, you can use one-to-one properties. One-to-one properties are very helpful because we can eliminate the logarithm or the exponential function using one-to-one properties. So we want to do that when we can. If an equation has several logarithms, then you want to combine using the product and the quotient rules. So anytime you can condense 2 logarithms to 1, and that only happens when you've got the same base. But when you got the same base, you can apply your product and your quotient rules. And then if an equation has only exponential expressions with different bases on each side, then you might want to take the natural log or the common log of each side and work with the power rule. So we would take the natural or the common log of each side and then use the power rule to simplify. Now that's a whole lot of stuff, but I'm starting with the first example, which has 3 totally different problems with totally different strategies. And I want to talk you through the strategies, going back over some of the things that we just looked at. Okay, so this first one, when I see a single log on one side, I'm going back to basically number 1. If I see a single log on one side of the equation and not one on the other side, automatically I'm going to think that I'm going to use definition of a logarithm. So immediately, let me just give an explanation. So for A, I see a logarithm on one side only. immediately I'm going to use the definition of a logarithm. So I'll go ahead and work that one since we're talking about it. So definition of logarithm says x raised to the fourth power equals 16. Definition of a logarithm basically is just writing the logarithm in exponential form. So basically here I can take the fourth root of x and the fourth root of 16, and I get x equals 2. 2 raised to the fourth power equals 16. So therefore, x is 2. So once you get it in exponential form, you can either work it out in detail or you can just see that 2 raised to the fourth power. Now, if you need to do it this way, you can say, all right, well, I'm going to take the fourth root of both sides, and I'm going to get x equals 2. Or you can just do it in your head, knowing that you're looking for what number raised to the fourth power is 16, and that number is going to be 2. This problem, I have an exponential on one side and I just have a constant on the other side. So what strategy might I use here? Well, this tells us that we could take the logarithm of both sides and use the power rule. I also know I could write this as in the form of a logarithm. So I could go from exponential form to logarithm. So I know that's the base. So log base 5 of 29 is going to equal to 3x. And once I have log base 5 of 29, now I know I could use change of base. So I'm going to write log or natural log, it doesn't matter. Common log 29 over common log 5 equals 3x. And then if we wanted to approximate this answer, we would approximate the answer, or we would just divide both sides by 3. And we would get log 29 over 3 times log 5 equals x. This would be the exact answer. And sometimes you'll be asked for the exact answer. So I divided both sides by 3 here. And that would be the exact answer. And then you could punch it into your calculator using your log key and get a decimal approximation. So I'm going to do that as well. So I got 1, and usually we round these. Usually we round these to 4 decimal places. 1.021, no, 0.22. So that would be the approximate answer because we have to round. So basically I use definition of logarithm again here. I just used it backwards. I went from exponential form to logarithm form because I had to get the x out of the exponent. You can't solve it with the x in the exponent. Now, I'll show you another way to do that too, but that was one way, and that's they're very similar. That was just changing it from exponential form to logarithm form and then using change of base. And I'll show you another way, and you can pick in a few minutes on a different problem because I've got several of these to work with you. So I'll do the other way next time. I just want to show you two different ways. Some people understand the definition of logarithm better than taking the log of both sides. Now, this next one is so easy, you will just not even believe how easy it is, but you have to think about what's happening. This one is 3 to the 3x minus 4 equals 9 to the x. Now, I want to compare it to the previous problem. This one had an exponential. This one had a constant. There was no way to write this constant on the right. You see this one right here? If that had been a 25, I could have written that as 5 squared and then used the one-to-one property. But it was 29, so there wasn't a way to do that. So I had to use some kind of logarithm to do it. Now, on this one, I want you to notice that 9 is equal to 3 squared. If I use this one and rewrite the right-hand side of the problem, then I can use one-to-one. Same base, you can use one-to-one property. So 3 to the 3x minus 4 equals 3 squared to the x power. So I just rewrote 9 with the same base that I had on the left. You can't always do that, but when you can, it sure does make the problem easy. So now multiply those two. Now you can apply one-to-one property here. So I know that 3x minus 4 equals 2x. When you have the same base, then you can set the exponents equal to each other. And then I can just solve. So I'm going to move the 2x to the left. And at the same time, I'm going to add 4 over here to the right. So I'm going to cancel the 4 out, and I'm going to have x equals 4. And that's my favorite exponential equations to solve. Because no matter what, you can't solve an equation that has an x in an exponent until you get it out of the exponent. So you have to get it out of the exponent, and then you can solve for it. So logarithms most of the time are what we use to get the x out of the exponent. Exponential functions always have a variable in the exponent. Logarithms get them out. So that's the whole purpose of a logarithm, is to be able to solve for x when the x is in an exponential function. All right, so we've got more strategies that we can use. This strategy I would use here. Notice I have base 2, base 2, base 2. Immediately, I want to figure out how I can use the one-to-one property. Because I have like bases on both sides of the equation. So I have the same base of the logarithm on both sides. So if I could rewrite one side to where I got a single logarithm, We have the same log base 2 on both sides. So if I could combine the left-hand side, I could use the one-to-one property. So for sure, this is what I'm trying to get to here. Over here on the right, this is a plus. So that means I could use the product rule to write a single logarithm. We just did that last time. So we can write log base 2 of x times x plus 2 equals log base 2 of 6x plus 1. And now I have one-to-one property. I'll go ahead and distribute here. So that would be x squared plus 2x. This is probably going to require me to have a new slide, so I'm going to go ahead and put one in. So now I can use one-to-one. So I can say x squared plus 2x equals 6x plus 1. And now I've got a quadratic equation. I've just got to get it equal to 0 and see if I can factor it. And if I can't, then I'm going to have to use the quadratic formula. So what I see here, and you really have to know this, you can't solve this any other way than this is a quadratic. So I've got to set it equal to 0. And then I've got to see if I can factor it or use the quadratic formula. So I need to move everything over to the left. That will not factor because I can't, there's no factors I can multiply to get 1 and add to get 4. So factoring's not an option. Don't try to factor something if it won't factor. So I'm going to use the quadratic formula. If you love completing the square, you could use completing the square as well. I'm just going to use the quadratic equation. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So here I can pick out my a is 1, my b is negative 4, and my c is negative 1. So plug into the quadratic formula. Negative b means change the sign. So positive 4 since it was negative in the equation. Then negative 4, put it in parentheses and square it or you're going to get the wrong answer. 4 times 1 times negative 1 all over 2 times 1. So that's 16 plus 4. Minus 4 times 1 times negative 1 is plus 4. Be real careful about that. So that's 4 plus or minus the square root of 20 over 2. That answer will get you most credit, but 20, remember, it will break down because it has a perfect square of 4 as a factor. So I could write 4 times 5. Square root of 4 times the square root of 5 is 2 square root of 5. So 4 plus or minus 2 square root of 5 over 2. Then you can simplify by separating. 4 over 2, 2 square root of 5 over 2. You have to separate those terms and divide by 2 on each term. So 2 plus or minus 2 square root of 5. Now let me warn you, if you didn't notice before, I think in Math Lab, you have to type out 2 plus 2 square root of 5 and 2 minus 2 square root of 5, I believe. So you see that those quadratic equations and all that stuff we learned in chapter 1, it never goes away. That's the reason I told you it was critical to be able to do the chapter 1 stuff. So if you weren't very good with chapter 1, it's going to continue to come back and cause you problems. So you just have to practice. Even if you're not good at factoring, you can get good at solving the quadratic equation because it never changes and it works for every problem as long as you set it equal to 0. So you can just practice using the quadratic formula and you should be set. Any questions on that problem? So I'm going to take a breather for a second and see. Any questions on what we did? So when you get rid of the logarithms in the first part, then you've done the part with this section. But now you have to go to finish to get all your credit. So this is a lot of stuff, but know your logarithm rules. And then when you get to that point right there, then you should kick back to your chapter 1 knowledge on solving equations. And if it's a quadratic, the only way you don't try to divide by x and all that mess I've seen. Set the equation equal to 0 when you got an x squared. Set it equal to 0 and solve using the quadratic formula or factoring. Or if you love completing the square, you can complete the square. All right, this one actually should be, I don't know where the rest of my equal went, but this should have an equal sign right here. So if you have one that doesn't have an equal sign, put that equal sign in. Now, this one, I'm going to show you a different method because the last time I worked this problem, I worked a problem, let's see, which one was it? B. Looks very similar. I worked it by definition of logarithm, by rewriting the exponential as a logarithm. So that's one way to work a problem like this. I'm going to show you another way. We don't have like bases on each side. And we can't write 99 as an exponent of 5. So we don't have any chance of using 1-to-1 right here. So let's try this method. So this is an alternative method or alternate method. From what I did in problem C. And most people, well, I'm not going to say most. Some people like to just use the definition of the logarithm because they know it real well. So I'm going to say this so you'll have it. So in example 1C, this is a different method. This method says, let's take the natural log or the common log. Common log base 10. So take the natural log or the common log on both sides. So literally, I'm going to say natural log of 5 to the 2x minus 1 equals natural log of 99. So just like anything else we do to an equation, as long as we do the same thing to both sides, we're good. Now use the power rule on the left. So the power rule says this exponent can come back in front, but let's put it in parentheses so it won't be confusing. Bring the power in front of the natural log, but make sure you use parentheses around it because it is a binomial. All right, now, is it asking us for, okay, so it's not really asking us for exact or approximate, so we're going to do both. So we're going to find exact, which means we're not going to punch those into the calculator and get an answer. And then we are going to punch it in and find approximate. So I need to solve this equation for x. So I have some things I need to do to solve this equation for x. The first thing is, because this is in parentheses and it had to be, I've got to divide both sides by natural log 5. So I think I'm going to need another slide added in again. Just so I won't have to cram everything up. So I'm going to rewrite what I have right here. So I want to solve for x, so I'm dividing by natural log of 5 on both sides. So this is what I did. Divide by natural log 5 on both sides. So that gives me 2x, whoops, got to change back. So that leaves me with 2x minus 1 on the left, and I have natural log of 99 over natural log of 5. So at this point, if I was going to get an approximate answer, I would literally type that in the calculator and get a decimal right now. But I'm going to get the exact first. I hope y'all don't mind me writing my natural logs as cursive. I'm so in a habit of doing that. So I've still got to solve for x. So I'm trying to get, this is what I'm trying to get. What is x? So I got to add 1 to both sides. So plus 1, so I get 2x equals natural log of 99 over natural log of 5 plus 1. And now I've got to divide both sides by 2. So I'm going to divide both sides, and I'm just going to do these two separately. I'm going to divide by the 2 right there. If I do it underneath, Let me show you to the side what that looks like in case you're confused. If I divide that whole thing by 2, what I'm really going to do is multiply by 1/2, because remember, that's a complex fraction. So natural log of 99 over natural log of 5 divided by 2 means multiply by 1/2. So really, I'm multiplying by 1/2 right here is what I did. So the 2 ends up right here. So let me write this: divide by 2, divide by 2, divide by 2. Now I can finish, because now I have x equals natural log of 99 over 2 natural log of 5 plus 1/2. That's the exact answer. So if they ask for exact, that's what you have to give. Now, if they ask for approximate, I would go back to this step right here where we have 2x minus 1 equals natural log 99 over, if you haven't already gotten it, the exact answer, you can go from this point right here, you can change natural log 99 over natural log 5 to a decimal right there. But since we already have it, you'll just type it into the calculator. But it's a lot easier if you have to get approximate to right here is where you would change to decimals and then add 1 divided by 2. So maybe I'll go ahead and show you that. So if I wasn't asked to find an exact answer, I would have this. I would go ahead and plug into the calculator and get that. So natural log 99. So I would have 2x minus 1 equals 2.8551, 4 decimal places. Then I would add 1 to both sides. So I have 2x equals 3.8551. And now I would just divide by 2. So about 1.9276 rounded to 4 decimal places. So this would be your exact. This would be your approximate. If they didn't ask for exact, then I wouldn't go through this part right here. I would change it. I would go back to this point right here, and I would change all this to decimals and then solve for x. So be careful about exact and approximate. If it's approximate, you can plug into the calculator basically as soon as you're in a position to do that. If it says exact, then you can't plug it in the calculator because you can't, this is an approximate answer right here. So it's not exact, but this one is exact. So that's an approximate answer. All right, let's go to another type problem. So we got all types of problems that we can work. Here's another one where I've got exponentials on, well, I got exponentials on both sides. I don't have the same base. If I don't have the same base, I can't rewrite anything. So what happens? Well, for sure, if I've got an exponential on both sides and I can't write one with the same base as the other, they're like, in other words, 5 is not can't be written as an exponent of 3. So I would just go ahead with take the natural log or the common log of both sides. Okay, so let's get the natural log of both sides, or you could use common log. Natural log, I use it because it's shorter. That's just lazy, isn't it? So I use natural log on both sides. And the reason I do that is because now I can use the power rule to get the x out of the exponents. So that's why we do that, is so we can use the power rule, and we bring this around and we have 2x minus 1 natural log of 3. And we bring this around and we have x natural log of 5. This one takes a little doing here. Because you got x's on both sides. Now, if I was going to do an approximate solution, we'll do both. But if I'm going to do an approximate solution, so let's do the approximate first. I would go ahead and punch these natural logs in and get a decimal right now. And just don't round it off too much or it will skew your answer. So let's round it to like 4 decimal places. So 2x minus 1, natural log of 3 is 1.0986. If I round it too much, I'm going to get not an answer close enough if I round too much. So natural log of 5 is 1.6094. You can see the logarithm rules are not that hard. What gets people in this chapter is the algebra, because some people don't have a very good algebra background. And if they don't have a good algebra background, they find difficulty when we get to this point right here. So that's X, because I had an X right there. So now I've got to use the distributive property. So I've got to distribute right here. So I get 2.1936x minus 1.0986 equals 1.6094x. Got a lot of decimals, but it's just an equation. It's an equation with variables on both sides. Doesn't matter which way you move your stuff. Since I already have an x over here, if I move it over, then I've got to move this one over. I did that before, but right now I'm just going to move this term over. with its like term. So I'm going to subtract it from both sides. So on the left, I'm going to have negative 1.0986 equals negative 0.5842x. So then I can divide both sides by this decimal. It's just solving an equation. That's algebra 1. It's just got decimals in it. This process is the same though. So I get 1.8805. I'll tell you, the algebra is what gets people in every class after algebra. If you don't get that algebra skills down, it just kills you in your next few classes. So I'm not going to do the exact on this one. I promise it's harder, and I won't give you one like that. I'll go ahead and just I'll ask you to give me an approximate like that. I don't think in Math Lab you have to do an exact answer on one that complicated. The algebra is very difficult, so I'll let you off the hook on that one for the exact. I would say try it though. If you want to try it, that would be good. Just to see if you can do the algebra. The better your algebra is, the more likely you're going to be successful in any math classes if you have to take them past this. But at this point in math, the algebra is what gets people. All right, so we're just going to keep doing, we're going to do another one. All right, this one has log on one side. So I want to rewrite. I know I want to get, since these are the same base here, log base 4, log base 4, then I want to rewrite as one log on the left. So I want to write it as a single logarithm. So I'm going to write log base 4. And this is subtraction, so that means I have to use the quotient rule. So the quotient rule says I'm going to have x plus 3 over 5x minus 1. So I use the quotient rule. Now I'm going to use definition of logarithm to rewrite. So I'm going to go from log form to exponential form. So log form to exponential form. So I've got 4 raised to the third power equals the parentheses. So that gets me 64 equals x plus 3 over 5x minus 1. Now, we solved some problems like this. It's a rational function. I showed you how just to put the 64 over 1 and cross multiply, but some of you didn't like that. So I'm going to multiply both sides of this equation by 5x minus 1 by the denominator, because that's a skill that we always use, is multiplying by the common denominator. So that cancels it out on this side. So distribute the 64, and I have 320x minus 64 equals x plus 3. So I need to get my x's on one side and my non-x's on the other. So I'm going to subtract x from both sides. So that's a 1x. And I'm going to add 64 to both sides. So I'm getting my numbers on one side. So these cancel on this side, these cancel on this side. So I have 319x equals 67. So I get x equals 0.2100. So if it says 4 decimal places in Math Lab, go ahead and put the 2 zeros. But 2.21 would be a good answer for that. All right, y'all tell me what you think about that. Difficult? Anybody? Anybody want to comment on what you think about these? All right, I'm back. So we've got some wind coming up here again for some reason, and I lost connection, so I had to get on my hotspot. Let's see if I need to plug my phone up. My battery's not that great, so it won't last very long. Okay, so I apologize. So let me share my screen. I think I only have maybe um, 2 more examples I'm going to go over. I actually have 3, but I'm not going to test you on one of them. I just wanted to show you a pretty fun application using logarithms. It's fun to me because I love logarithms, but it wouldn't be fun to you to do on a test, I don't think. This one's pretty easy because if you remember back, and I give you this formula so you won't have any problem, but just remember that when you're dealing with interest or interest paid or interest earned, remember if it's compounding continuously, you always use this formula. So you're just plugging into that formula here and solving for whatever they're asking for. So the main thing is fix the question write down the information. How much must be deposited today? Here's a key word, today, to become 5,000 in 10 years. All right, so here's what we have to say. Remember, the A is the amount. So A is the amount after T years. P is the principal. Well, so if I can spell. I'm tired. I didn't get much sleep. P is the principal, or this is your initial deposit or your initial cost. So it's whatever the initial deposit is. So we want to solve for P. So we have A because it says we want it to become 5,000 in 10 years. So A is 5,000. T is 10, and the rate of interest is 6.5. So 0.065. Change it to a decimal. P is what we're looking for. How much should we deposit today? What is that principal? So I'm just going to plug in 5,000 for A, and then E raised to the 0.065 times 10. So you can see we've got to divide both sides by this. So 10 times that's just going to be 0.65. So I'm going to go ahead and multiply those two and get 0.65. So I'm going to divide both sides. By e to the 0.65. I've already multiplied. And that will give us, so that will cancel that out. So that's going to give us our P. So on your calculator, you want to do 5,000 divided by, and find your E. On most calculators, it's above the LN key. Yes. Come in. I'm teaching, but I know I'm almost through. Are y'all hungry?
A little bit.
Preheat the oven and we'll get the pizzas in.
How hot?
At 450. Sorry about that. My teenager just came in hungry. Okay, so I'm doing 5,000 divided by e to the 0.65, and I am getting $2,610.23. So we have to approximate it to the nearest cent. So that's what I got. That's how much you would have to deposit today, and then have 5,000 in 10 years at 6.5. That's pretty good. I would like to deposit something like that and almost double it in 10 years. That'd be a good deal. All right, I've only got one more example I'm going to work with you. This next one I gave to you and it's already worked out. I just want to show you a few things about it. A couple still owes $90,000 on a house that is financed at 8%, which is pretty bad these days. Annual interest compounding monthly. If they start paying $1,200 a month, then when will the loan be paid off? So there's a particular formula you would have to use, and this is the formula that you would have to do. It's part of the amortization formula that banks use. But look, I'm not going to make you learn how to do this by hand. because if you're a banker, you're going to have a computer that's already programmed to do this type stuff. But I am just going to show you how interesting it is to solve a problem like this. So you want to plug into that formula. Here you've got R is 1200. That's going to be your monthly rate that you're paying. The principal, that's the P is how much you still owe. That's the principal that you still owe on that house. And then you've got N is 12, and then your interest is 0.08 divided by 12. So I is going to be the interest divided by 12. All right. So you plug in. Once you, let's see what we do here. Well, we multiplied both sides by this denominator because we were solving, here's what we're solving for. See that T right there? It's in an exponent and it's in the denominator. So we have to get it out of the denominator first. So we're multiplying by that on both sides. So that's how this got to be over here. And then we're dividing both sides by 1200. So we're trying to get to T, but we got to simplify it as much as we can to be able to get that T out of that exponent. So we divided by 1200 on both sides. Then we reverse sides. I don't know why we reverse sides, but take the natural log of both sides. And then, so natural log, and use the exponent rule. So power rule. Now you've got that out of the exponent. And now you can just solve for T by dividing by everything else. So you would want to divide both sides. Divide both sides by -12 natural log of 1.005 on both sides. So -12 natural log 1.005. And it ends up saying you can pay it off in 8.6932 years. Now, I am not going to make you do one like that. So I just wanted to show you how you could use logarithms to get complicated equations solved for a certain variable. The key is you're trying to get it out of the exponent. It's good. I'm on my hotspot. All right, so this one is exponential growth and decay. I don't know if I gave you one in math lab like this or not, but it's also something good if you're going to take upper level courses to understand exponential growth and decay. Exponential growth has to be an increasing function. So this looks like exponential growth. Something like this looks like exponential decay. And we express the exponential model in base E. So basically we use natural logs or E. So which one would this be? Well, we're decreasing left to right, so it's a decay model. It's decaying exponentially. And this is the growth and decay equation. This A sub 0 right here, that's the initial amount or the amount at time 0. So I always think about it, it's at amount at T equals 0. K is the constant of growth, and you either have to calculate it or you have to be given it. K is positive if it's growing, and it's negative if it's shrinking. So exponential growth will have a positive K, and exponential decay, like radioactive substances or medicine, the K is going to be a negative number. Um, the half life of an antidepressant Prozac in an average man is 2 days. How long does it take for 95% of the original dose to be eliminated from the man's body? All right, so I have a terrible phone. I'm on my hotspot. I didn't charge it before. I didn't charge it because I didn't think sure we weren't going to lose power again. But we did. So I've lost power again. They're probably just cut it off to work on the line. So I really don't have a way to continue very much long because I didn't charge my. I was going to need my hotspot, so I didn't charge it. So it's going to die. So I will tell you that you can look this problem up in your textbook or your ebook. So textbook or ebook. Use my flashlight here to see what page number that is. I'm in the dark. Page 319, example 6. So if you'll look that example up, then I can still work it if I need to work it before we take the test. But this concludes this. So the next time we're going to review. So before next time, either do the paper study guide, and you might want to do both of them, like I said, but you need to do the math lab one because it's 20 points. If you want those 20 points, if you don't mind dropping that grade, it'll be one of 3. Or do the paper copy. Okay. The paper copy, I'm going to put a drop box in, a work submission box, so you can earn 5 bonus points if you do that. I would say do both just because it's going to be good practice and you need the practice on these. I'm sure you need the practice on the equations, and some of them are real short problems, so they don't take long. So I'm going to stop for today, and I'll be posting you some information on Canvas